Alright, I want to help you solve this problem here. To perform the indicated operation, and the operation that we're doing is subtraction. And anytime we subtract or add fractions, we always need an LCD. We need a least common denominator. So we want these two denominators to look exactly the same. And right now it might be a little tricky to determine what the LCD is. So to determine what the LCD is, let's start by factoring each of these denominators. I'm going to factor each one, slide this down a little bit, so that hopefully the LCD will magically appear, or at least you'll be able to see what the LCD is a lot easier. Alright, you should be able to recognize this. This thing here is a difference of squares. So a difference of squares can easily be factored into two factors that look exactly the same except that their signs are different. So in this case it's x plus 2 and x minus 2. I'm going to make the denominator look like that instead. And this here, trinomial, can be factored further as well into x minus 2 and x minus 2. This is actually, these two parentheses are exactly the same. It's called a perfect square trinomial. Alright, so we've factored both of those denominators, and now that you see that, hopefully it's easier to see that the LCD in this case is going to be one of these x plus 2's and two of these x minus 2's. One of the things I mentioned in class is that the LCD, even though we're looking for the least common denominator, we're actually thinking the greatest. We're actually thinking the opposite. So I at most see 1x plus 2, and at most I see, well, this guy here has 1x minus 2, but this one has two of them. And since 2 is bigger than 1, I'm going to have two x minus 2's in my denominator. Okay, so here is my LCD. Now, the next question you ask yourself, and the process is the same for any adding and subtracting of fractions, is how do I get this denominator, let's work on this one first, how do I get that denominator to look like this LCD? Well, it's already got the plus 2 rather, and it's got one of these x minus 2's, but it's missing one more x minus 2. Well, that's what the numerator also gets multiplied by. Alright, if I was to multiply this denominator by one more x minus 2, it looks like this LCD now. Well, if I do that, I also have to do the same thing to the numerator. I have to also multiply it by whatever term was missing. So I hope you see if I distribute that this turns into x squared minus 2x, easy enough. And then you ask yourself the same question, what is this denominator missing to make it look like the LCD? Well, it's already got two x minus 2's, it's missing the x plus 2. That's what we multiply not only the denominator by, but the numerator as well. So I got to put an x plus 2. Okay, so now I've got the LCD, just going to write it once. My new numerator over here is this stuff. And 1 times x plus 2, well, that doesn't change it, it's just x plus 2. Now I'm writing it up there because I hope you see that this minus sign that's sitting in between these two terms is going to affect both of these terms after it. It's going to change both of them. If that was a plus sign, it wouldn't change that x plus 2. I'd just bring it on down. But because it's a minus sign, it's going to change both of these, and so it's going to be a negative x now, or a minus x, and instead of a plus 2, it's going to be a minus 2. So watch out for those minus signs. Okay, I'm almost done with this problem. I'm going to do one more thing. I'm just going to clean up the numerator because I see two terms that are alike that I can pull together. These guys are like terms. And our final answer then is going to be x squared minus 3x, right? Because negative 2x added to a negative 1x is a negative 3x. And we're adding up top there. All over this LCD of x plus 2. And how about we get fancy and we write x minus 2 just once with a square outside of it, since there were two of them. And there you go, that's our final answer. Now normally I would try to factor this numerator a little bit more and maybe simplify with something that's in the denominator, but it turns out that you cannot factor this numerator anymore. There it is, final answer.